Raj, in this functions video, we're going to be looking at quadratics and completing the square. And hopefully by the end of this video, you'll be able to look at a quadratic equation on a graph and be able to write down what that quadratic equation is. To help us along this path, we're going to use this website called GeoGebra. So if you can open that on your browser, you'll have a little bit of fun with this hopefully. And click on Start Calculator. So what you should see is something that looks like this. You can see here it's asking me to sign in. You don't need to sign in. You can if you want, and you can save all your graphs. I just go in and I use it and put new ones in each time. So this plus button here is what we're going to press, and it should bring up a calculator for you. If it doesn't bring the calculator up straight away, it may bring up this box here. What I want you to click on is f of x. As you know, we're going to be looking at functions here, so it should be a little bracket there, f of x for expression. And then we're going to use the calculator to type in x squared. If the calculator doesn't pop up, just click down here. There's a calculator function down here. So you should see the calculator pop up. So the x, we can just click on here. We can make it a squared by clicking on this one. And obviously we can use the plus and minus buttons. We can also use the keyboard on a calculator, but I find this one a little bit easier maybe just to use if we want to type anything in. And it's definitely easier than drawing an x and y axis in our copies and having to do the whole table. So I think make GeoGebra your friend, Raj, between now and the end of 6th year, because it makes everything really visual. You can come up with your quadratics really quickly. You don't have to stress about graphing, putting pen to paper. And in the exam itself, you're always given the graph, you're given the x and y axis, so you're never really going to have to do it by hand. I know I make you do it in class, but it's just really to get you practicing. So I want you to type in x squared, and let's see what it looks like. You can zoom in and out as well for the scale to go up and down, which we'll see what that looks like as well. So this is what you should get. You should be able to zoom in and out on the screen if you have a touch screen, so you can really get a great image of these guys. You can play around with them. So your basic y is equal to x squared, you can see goes through the point 1, 1, and minus 1, 1, it goes through the point 2, and 2 squared 4, 2, 4, and minus 2 squared is also 4. You can see we have points of intersection. Along the lines y is equal to 1, 2, 3, and 4. And you can see here we don't have a point of intersection along here. And maybe think of surjective, injective, bijective in relation to this. Now, what would happen if we added 1 on to all of the answers on the y-axis? Would it go this way? Or would it go this way? So type in to GeoGebra x squared plus 1 and x squared plus 2, and let's have a look at what they look like on the graph beside this one. So I've actually brought 1 up and 1 down. So x squared plus 1, you can see just moves it up here. What point of intersection is that? The point 0x, 1 on y. And then why am I saying this? Because this is the minimum point, which we're going to look at next. The minimum point of these graphs, the point at which there is nothing below it. What's the minimum point of this graph? 0, minus 2. So I'm just going to introduce some maths in relation to these minimum points. So let's have a look at introducing minimum points. And when we're going to get to calculus, you're going to hear a lot the word minimum or maximum. So minimum points, we've kind of introduced there. The bottom of a quadratic is going to be your minimum point. And if we have cubics that look like this, we're going to have a max and a min. And with our minus x squared, we'll also have a max, not a min. So with our calculus rules, differentiation, as you know, Raj, you bring the power in front and reduce the power by 1, which we can write as dy dx, change in y over change in x, would be equal to 2x in this case. And if I change this one on the right to be f of x is equal to, we'll just have a look that we can also write this as f prime x, or f dash x, would also be equal to 2x. The constant goes to 0 in both cases. So the point when x is 0, which is what we had on our graphs, we want to get the slope at the point x is equal to 0, or we let our differentiated function equal 0 to find where x is at the minimum point, and x is equal to 0 in both cases. Here I don't need to solve it, you're too smart for that. So just introducing a minimum point now before we bring in an x into these equations. You can see we just have an x squared and a constant. So let's have a look. Something unusual happens here when we add the x. Maybe it's counterintuitive to what you would think. So let's have a look at a couple of graphs, maybe x squared plus x first. So if you leave y is equal to x squared on the table and add in, you can click on the 3 dots here to delete any functions you've had previously and add in for me, Raj, x squared plus x, and it should come up in black. You can change the colors if you want. You can see here we can add any amount of graphs that we want. So x squared plus x, intuitively maybe you would think it would shift it to the right because it's positive. But if we look at the minimum point of this graph, x squared plus x, it's called g of x here. Let's still call it g of x is equal to x squared plus x. So g prime x is equal to, in this case, 2x plus 1, I hope you're saying. We let that equal 0. So we say 2x equals minus 1, x equals minus 1 over 2. Don't be tempted to skip stages. Put every stage in and don't make a mistake. Now, always with the minimum point, we can see here x is equal to minus a half, which is here, and our minimum point is down here. So the graph has shifted this way negatively and down, which is also negatively, even though we have 2 plus signs in here. And let's see why. If we put negative a half into g of x, so g of negative a half, write down exactly what you're doing. G of negative a half is negative a half to be squared plus negative a half. If you want, just write it out the way it's given to you. Your calculator will do it for you. So this will be equal to, and you could be tempted maybe to write each answer out, but just type this into your calculator and your calculator will give you the answer. It's going to be a quarter. Sorry, and you can see what I've done here. What have I done? I've left out the negative just as I'm about to type it into my calculator. It's going to be a quarter minus a half, which is minus 1 over 4. So the minimum point here is when x is equal to negative a half, y is equal to minus a quarter. And just double check, does that match up on our graph? Just rub these lines out. You can see here it matches up on our graph. It's about halfway down there between minus a half and 0. Not about, it's exactly halfway down. So you can see here this minimum point. So it shifts it across and down. Now let's have a look at completing the square here. This is where we start introducing a nice bit of algebra mixed with functions and mixed with calculus. So we have g of x is equal to x squared plus x. So the great thing about completing the square, and we should probably put a heading in. So the great thing about completing the square is that it kind of takes us from that junior cert, we're just graphing them and what are quadratics, into really when we see a quadratic on a graph, we can see what the equation of that quadratic is. And hopefully, Raj, that's the plan today, is to be able to look at these graphs by the end of today's lesson and to write down exactly what they are with the completing the square method. This is the key. So let's have a look at the first connection between this equation and how it looks on a graph. If we want to get x squared, we'd have to have x inside a bracket and a squared outside a bracket. And to get x itself, we'd have to have x plus a half the coefficient of this number. So if you imagine x squared plus 2x, we'd have to have x plus 1 in a bracket to be squared. Now we'd have another number here that we don't want, which is what we're going to introduce here. So to get x squared plus x, you'd have to have x plus a half to be squared. This would give x squared plus a half x plus a half x plus a half by half, which is a quarter. I think we've mentioned the quarter already. So that's, don't forget your x, that's x squared plus x plus a quarter. Now, that's not what g of x is. G of x is equal to x squared plus x. So I would have to take away a quarter here to balance it off. So you can see that g of x could also be written as x plus a quarter, plus a half to be squared, which will give you the x squared plus x plus a quarter. So what do I have to do? I have to take away a quarter. So you can see here we got our minimum point to be minus a half, so change the sign, keep the sign will be how we'll identify these graphs. Now starting with a fraction is probably a little bit tricky, so I'm going to show you a slightly easier one and then maybe come back and look at this one again a second time. So let's solve it first and then let's see how it looks on GeoGebra. So x squared plus 4x. Let's find the minimum point. H prime x is 2x plus 4. 2x plus 4 is equal to 0. You could just put the equal 0 there if you wanted. 2x equals minus 4. X equals, and when you get good at them, Raj, you should start seeing the answer as they come rather than jumping there too quickly. And if x is equal to minus 2, h of minus 2 laid out the same way each time is equal to minus 2 to be squared plus 4 times minus 2, which is 4 minus 8, which is minus 4. So the minimum point, write down what it is, the minimum point is minus 2 minus 4. So let's look at completing the square. So we've got x squared plus 4x. We'd have to have x plus 2 to be squared to get x squared plus 4x. Now what have we got here, Raj? We've x squared plus 4x, but we have that plus 4 that we don't want. And you know this is how I teach it in class. So we'd have to take away that 4 to balance it off. So you can see here that my min point is change the sign, keep the number minus 2 minus 4. So a couple of little different ways to get the minimum point. Why do we do the completing the square method? Well, let's see how this looks on a graph. This x plus 2 to be squared minus 4. So this is how it looks. Now let's write down the minimum point. Minus 2 minus 4, which was x plus 2 to be squared minus 4. So what's happened is it has shifted across 2. So it's gone left 2 and it's gone down 4. Out 2, left 2 and down 4. So now what I'm going to challenge you to do, I'm going to give you a quadratic. I want you to complete the square and I want you to do a sketch of it before you look at it on GeoGebra. So this one, Raj, y is equal to x squared plus 2x plus 3. Complete the square for me and do a sketch of it. Pause the video. Okay, hopefully you've given it a good go. Let's have a look here. We want to complete the square. We can do x plus 1 to be squared, which is x squared plus 2x plus 1. So I'd have to add 2. Hopefully you can just jump to that in one stage. You could do here the plus 1 that we shouldn't have. We need plus 3, so you'd have to add 2. So what's going to happen with this? We're going to go left 1 and we're going to go up 2. Let's just check that with the min point. dy dx is equal to 2x plus 2. Let that equal 0. If you're in an exam, you have something like this, you'd always do as much as you can just to double check your answer. Make sure you're right. X is minus 1. So y is equal to minus 1 squared plus 2 times minus 1 plus 3 minus 1 minus 2 plus 3 . And I hope you're roaring at the mistake, because if you type this into a calculator, what are you going to get? You're going to get the 2, because that's a plus 1. So that's why you use a calculator in an exam, a little lesson. So you can see here the minimum point is minus 1, 2. The y-intercept is plus 3. So if I ask you to do a sketch, this is what I would expect. Really quickly, there's minus 1, 1, 2, 3. Minus 1, 2 is the minimum point, which will be there. It goes through the y-axis at 3, so it's coming down like this. And I'm hoping you're identifying something with these two. We've done complex numbers. These are where there's no real solutions for these graphs, not crossing through the x-axis just for sketching purposes. But something like this, Raj, will be a good enough sketch for me, just to show that you have knowledge of, or getting to have knowledge of, the minimum point, what these quadratics look like, what happens when you add an x and then add a number. And hopefully you're seeing that by completing the square we get that shifting up. It's not the 3 at the end, it's actually what we have to add or subtract at the end to move the quadratic up or down. So let's have another one of these to try. And before we do, we'll look at this, type this into GeoGebra and just double check to see what it looks like, and we'll have a look here too. So you can see here, left 1 and up 2, get your min point. You've got the y-intercept and should look like your sketch. It's not easy to draw them, but just get used to drawing some sort of a curve. Maybe draw an x and y axis yourself, obviously in your copy, and get used to sketching them too. So GeoGebra sketching. Let's try maybe 2 more of these before we move on to maybe then starting some of the questions that will get asked. So again, Raj, I'm asking you to take this down, pause the video, whatever way you want to do it. Complete the square, find the min point, sketch it for me. Okay, so this will be my attempt, x minus 2. Now, that's the first one we see with a minus. That's the opposite to a plus, obviously. X minus 2 to be squared is x squared minus 4x plus 4. We want plus 7, so I'd have to add 3. So to me, this one is going right this time, 2, and it's going up 3. So my sketch would be the minimum point would have to be 2, 3. Change the sign, keep the number. 1, 2, 1, 2, 3, 4. Why am I going higher? 5, 6, 7. That's where it crosses here. So the minimum point at 2, 3. Crossing up here. Just change the color for the axes or for the diagram. Down and up. And that's the kind of sketch that I'm expecting here. 3 and a 2, just put your values in. Let's just check that min point. H prime x is equal to 2x minus 4. Let that equal 0. 2x equals 4. X equals 2. We have that. H of 2 is calculator use, so you don't do what I do and make mistakes. 2 squared minus 4 times 2 plus 7. If you type into your calculator, you're going to get 11 minus 8. Calculator will do it for you. 3. So you can see the minimum point is 2, 3. I'm going to introduce just the slope of this line. You know is equal to 0. That's why we're letting h prime x equal 0. How does this look in GeoGebra? Let's hope it looks the same. So you can see your shift and Raj to completing the square, plus 2 and up 3. And the intercept being 7. Obviously, we've just drawn it down to scale here. So hopefully you're getting good at these. I'm going to get you to practice one more of these, and then we're going to have a look at some of the graphs, and then you're going to write down what the quadratic is, and then hopefully you've mastered this section. So I want you to pause the video and do the completing the square method to sketch this quadratic h of x. Hopefully this is what you've done and you're getting really good at them. You can see repetition all of a sudden makes it easy. X plus 3 to be squared is x squared plus 6x plus 9, so we'd have to add another 4. So the min point here, Raj, minus 3, 4, the y-intercept at 13. I'm just going to do something like this. So what if we do a sketch like this? And we put nothing on the diagram. So all we need to do now is put our numbers on. I know this is on the wrong side of the x-axis, but just for sketching purposes. Where do we come? Minus 3. How high do we go? 4. And that's how quickly these can be done. Now, from seeing a graph like this, from seeing the minimum point, seeing the intercept, let's have a look. Can you now write down the quadratic? Okay, Raj, what's the quadratic? How quickly can you get to it? What knowledge do you have so far? Look at this min point here. Left 2, so what do you know? Plus 2, you've paused the video, but you've already done this, and down 6, minus 6 down that way. So minus 2 minus 6 would lead us to a quadratic that would be x plus 2 to be squared minus 6, which would be x squared plus 4x plus 4 minus 6, which would be x squared plus 4x minus 2. Complete the square of this one. X plus 2 to be squared to get x squared plus 4x plus 4. But we don't want plus 4, we want minus 2, so I'd have to take away 6. So you can see this one is the same as this one. And you are now a master of identifying quadratics, as well as sketching them, solving them, minimum points. So let's look at 2 more of these to prove your mastery. And then we'll move on to the next part of functions. Okay, Raj, what function is this? What can you identify? Minimum point is 3 minus 6. Let's just check our y-intercept on this one as well. So you're going to have x minus 3 to be squared, as you've already written down, minus 6, which is x squared minus 6x, plus 9 minus 6, which is x squared minus 6x, plus 3. Complete the square. X minus 3 to be squared will be x squared minus 6x, but we don't want that plus 9. We want plus 3. We'd have to take away 6. So it has gone right 3, plus 3, down 6. So hopefully now, Raj, you have nearly or absolutely mastered this topic. It's a great one to have the visuals behind it, and I would recommend making up your own ones and using GeoGebra a little bit to just get a little bit of extra mastery of this topic. So let's do one more before finishing up. Okay, try this one to finish up for me. Pause the video. So what do we see here? We see this minimum point, 1 minus 7. X minus 1 to be squared, you're telling me, or you've already written. Minus 7, which is x squared minus 2x. So it's the 2x gives this value of a 1. The 1x will give a value of a half. 4x gives a value of 2, and so on. I hope you're identifying these right at this point. So that's x squared minus 2x plus 1 minus 7, which would be x squared minus 2x minus 6 for this one. So hopefully you've had a bit of fun with this and you've learned a couple of new things. Functions, not that difficult. Minimum points, maximum points, completing the square, understanding how they look, Let's move on to the next lesson.